and we'll get some awesome live demos. Right.
So sorry for the delay, guys. We're just attaching an adapter to my laptop because it's a MacBook Air and it doesn't have a lot of ports. Okay. Yep, great. Excellent. Nope. So, am I audible? Okay, great. Right, so I'm going to talk about visualizing data in Python, and this is going to be a fairly pragmatic talk about Python libraries, because if you're like me, you probably have a tool set that you use to do everything, and you hear about all these other options, and you don't know whether you should take the time to go and check them out and maybe change what you're doing. And for those who don't know, Jake Vanderplas gave a very similarly themed talk at PyCon in the US earlier this year in May. So I'm going to do my best not to duplicate his talk. So this won't be such a high-level survey of libraries. If you want that, I highly recommend you watch his talk. It's online on the PyCon YouTube channel. But he came up with this diagram, which, as you can see, is bewildering, right? There's all these libraries. So if you hear about new things coming out and there's a lot of buzz, people are excited, but should I try it? It's really hard to know. And the fact that there's so many is kind of demotivating. It would actually be useful for me to be able to see the time as I talk. Could I borrow that one? Or similar? Actually, what I'm going to do is grab mine. Now, this is going to be a very time-challenged talk, because I'm going to try to do a demo, because I think one of the nice things about talking about interactive libraries is getting to see them working. So I apologize. I'm going to try to squash some things in, and at the same time, I'm going to have to leave a lot out. I obviously cannot possibly talk about all the things in this diagram, so I'm going to pick a few and wave my hands and talk a bit about the rest. So one of the nice things about this diagram is that, I don't know if it's very easy to see, but there are some hubs that things are organized around. They're in bold. So those are them. Maybe the change makes it easier to spot them. And the idea here is that some of these libraries are built on others. So there's a whole lot of visualization libraries that build on Matplotlib and use it under the hood. And then there's and they get the strengths of Matplotlib, which is that can render to a lot of image formats. It's got a lot of low-level control. You can tweak everything. There's other libraries that ship with a JavaScript library, or maybe use some pre-existing JavaScript library, and they use that for their rendering backend. So the Python library specifies a plot, hands it over to the JavaScript library, which renders it, and they get the strengths of JavaScript, which is, of course, interactivity. Right? There's a couple there that are built on OpenGL. The strength of that is using your GPU, rendering a large number of points very quickly. So I should also just point out on this plot, things I've just turned pink are not Python libraries. Most of these circles are Python libraries, but JavaScript is obviously a language. D3.js is a JavaScript library, and Vega is a JSON schema for declaratively specifying plots. And Vega Lite is another version of those same things. So they're there as hubs because there are things built on D3.js. Okay, so I'm going to talk a little bit about some libraries, and I'm going to flip over to the notebook and do a demo. I'm not going to tell you what Jupyter is, because probably everyone in this room knows, and if you don't, you'll see it. I'm not going to tell you what Pandas is, because ditto. I will just say, though, that Jupyter is probably a driver of some of the interactivity we're seeing in libraries these days, because so many of us now do our data exploration in the browser. Okay, so here's the data set I'm going to use as a demo. This is the National Electronic Injury Surveillance System. It's got some fields that are not listed here, but here are the fields I'm going to actually use. So this is a Pandas data frame, or a spreadsheet if you like. Every row is an incident, an injury incident, and these incidents get reported. What product was involved in the injury is kind of the point of the database. So you can see we've got the age of the patient, their sex, the date it happened on, the product. So there's the floor, there's basketball, there's ceilings and walls, where it happened, what body part was injured. And the nice thing about this one, this is kind of why I chose it, is that for most of the incidents, we have a little narrative, and that's nice for demonstrating some visualization features. So, you know, 17-year-old complains of hand pain after punching a wall in anger, right? You can't plot that stuff, but if you have interactive visualization, you can explore it. So, just really quickly, Matplotlib, I'm sure everyone knows of Matplotlib. It is the oldest of the plotting libraries in Python, really. It's been going a long time. It's still going strong, but usually now it's underpinning something else. Its original API was invented to mimic MATLAB because it helps people to switch over, which is probably not the interface we would want now. It does have an object-oriented API. Sometimes it's hard to find in the documentation how to do things one way versus the other way. It's very powerful. You can kind of do almost anything you want in Matplotlib, but sometimes it takes some effort. And it's probably worth mentioning that Matplotlib 2.0 came out this year, and Matplotlib is now a lot prettier by default. So it's updated the fonts, the color schemes, it's colorblind friendly, it doesn't have black lines around shapes by default, all that sort of stuff. I won't spend time on that. So the first thing I'm going to show you is Seaborn, and then I'll show you a couple of interactive things. Actually, I'll tell you now what I'm going to show you. I want to show you Seaborn, bokeh, and hollow views. And I picked those because I found them interesting and they fill very different niches. I apologize if I'm not going to get to your favorite tool or your tool. And if I have time, I hope I'll talk about some of the others, but not actually demo them. There's definitely others that are interesting on here. So bokeh's there, hollow views is there. So the niche that Seaborn fills is, it's been around for a while, it builds on Matplotlib, it gives you all the control that Matplotlib gives you because you can always fall back to Matplotlib and manipulate those objects directly. It is static, unless you use something else to add interactivity onto it. It just gives you static plots. It's very pretty, so you kind of get publication quality graphs out of the box with not a huge amount of effort. So let's switch over to a notebook already and start looking at some data. Now, is that legible, or do I need to make fonts bigger? I think that's probably okay. So this is our data frame. It's got a few fields. I've added this incident count field here, which is just 1 everywhere. Every incident has a count of 1. It means that when I want to do summary statistics, the names of my fields will make a bit more sense. So to start off, let's ask a question like, what products injure people most often? Just make a bar plot in Matplotlib. And you can see that people are most often injured by stairs. I should say there are lots of products in the Dust database. I've restricted us to the top 12 just so I don't have to fool around with that while I'm doing demos. The second culprit is the floor. The third culprit is basketball, which I find really impressive. There must be a lot of basketball going on in the US. And then beds, and then knives. And this is a straight Matplotlib plot. You can see it's a lot prettier than it would have been, say, last year. Matplotlib now has context managers. So if I switch to the classic style and remake this plot, you'll see this is probably older than last year, but this is what Matplotlib looked like once upon a time, right? It's pretty clunky. So looking at Seaborn, in Matplotlib, I had to add up all the numbers myself to get a bar plot. It doesn't do that for me. And then I had to specify where the edges of the boxes should be. Right? I had to say the bottom of each line should be here, and the length of each line should be the sum of my counts, and so on. In Seaborn, it knows about pandas, so I just say, my data is this data frame, my Y value is, I'll pick the location, my X value is the incident count, and please add them up. Right? And I get this plot of where do incidents occur. And as they're always telling you, most accidents happen in the home, it looks like. So home is the #1 place. Sports places are second. How are we going for time? All right. If I wanted, I could go back to our product and see that I could put a hue parameter on. So I could say, give me different colors for males and females. and it does that nicely. You can see that men get more injuries from basketball, women get more injuries from stairs. My personal theory is high heels are involved, but maybe we could look at narratives and find out. So it's fairly easy to make, for instance, something like this. Let's say, what parts of the body do people injure with different products using a heat map? Knives usually injure fingers. The floor usually injures the head. The ceiling or the wall, probably the wall, right, usually injures either the head or the hand. And the basketball usually injures your ankle, as do stairs. So it's a heat map, and a few things you can see here is that I didn't do much, and it's very pretty. Seaborn has automatically detected that my numbers are positive, so it's used a continuous colour scale from light to dark rather than a diverging colour scale with two colours, because I don't have positive and negative data. It's rotated the axis labels for me, everything's legible. It's nice, like I could put this in a paper, right? And it only took me a couple of lines. I'm just going to skim through stuff because I don't have enough time to spend on Seaborn by itself. We could ask, how old are the people who get injured by different products? Young people injure themselves with basketballs and footballs. Older people injure themselves with chairs and the floor. And finally, last one I'll do for Seaborn. This is a joint plot. It's just an example of putting together a fairly sophisticated visualization with very little code. It puts a histogram on each axis and some kind of scatter plot or density plot in the middle. So here I've done the day of the month. So this is 1 month in December. And I've said, what day of the month did the injury occur on and how old was the person? Just because those are continuous variables that I had available to me. You don't really expect that age will vary with day of the month. But in fact, because this is December, we can see that something happens over Christmas, which is that young people stop injuring themselves so much over Christmas. Which probably is because they stop playing basketball so much. I could have made this scatter plot, but it would be awful because it's the classic problem of overplotting, right? There's too many points in the data set. So some kind of density plot makes sense. Hex is nice. There's also a kernel density estimation that will give you contours. Okay, let's go back, or else we won't get to anything else. So Seaborn is really pretty, but it's totally static. Bokeh is an example of a library that has interactivity built in. Every plot you make is interactive at least a little bit. It's really a framework. It's all-encompassing. It ships with its own JavaScript library. It has its own widgets and things. It actually gives you quite good low-level control, even though it's not built on Matplotlib. They've implemented low-level control pretty well. I'd say a weakness, if at the time that the PyCon US talk was given, was that it couldn't export to SVG, but now it can. And I'd say I think a competitor is Plotly. It's probably in the same space. Possibly BQplot. Altair is up and coming. One weakness of Bokeh, perhaps, is that the BK charts package has less built-in plot types that it will just do for you than some of the competitors like Plotly. But of course that changes. And one strength of Bokeh is that other libraries are built on it. HoloViews is an example. So that kind of gives you the higher level libraries. So let's just quickly do a couple of examples of that. So this is the basic way that you make a plot in Bokeh. I've said, now this is the bit where I start to get nervous about internet connectivity and everything, as I do JavaScript demos in a notebook. I've said, draw me some circles, make the x-axis the day, and the y-axis the age. So it's conceptually the same as this. I've just taken a random subset of my data so that it will work, so that I don't have too many points, and I can demo it. So we get just a scatter plot, but because it is a JavaScript-based library, there's automatically a pan tool and a zoom tool, even if I don't ask for any other forms of interactivity. And it's pretty painless to switch on some other forms of interactivity. Here I've switched on a couple of different things. One is I've done male and female as two different elements of the legend, and I've turned on the legend click policy hide. So if I click male, all the male points disappear. The other feature I've turned on is a hover tool, and I've said, please give me the narrative in my hover tool, which means hopefully if I hover over a point, I can see the narratives, right? So we can choose whatever we want. There's an astonishing number of hand injuries on the walls. I didn't see that one, but I'm going to take your word for it. We are short on time, so I may skip over this. There's a BK charts package which lets you do higher level stuff like heat maps and bar plots and box plots and so on. And one thing that is worth demoing is that it's really easy in bokeh to link up two plots. So here, when I made my second, I've got two plots, P1 and P2. When I make my second one, I'm saying the X range should be the X range of the first one, and the Y range should be the Y range of the first one. So I've done one for basketball and one for stairs, and the consequence is that if I pan one of them, the other one should pan too, because I've specified that the X-axis should be the same. And if I zoom one of them, the other one should zoom too, right? There's also, I haven't got a demo of it, but it's very easy to link up plots so that if you select points in one, the corresponding points get selected in the other. All those things are really easy. It also ships with widgets and things. To do really sophisticated things with widgets, you need to not be using just a notebook. You need to run a bokeh server, or you need to write custom JavaScript callbacks. All right, so I've got some slides on Plotly and BQplot, and I'm actually not going to talk about them unless we have time at the end. You can ask me questions later because we are so rushed. But I do want to show you and demo HoloViews because it's kind of filling a niche that, so far as I know, nothing else is really filling. I found it very interesting. Their slogan is stop plotting your data, annotate your data, and let it visualize itself, which I found mystifying. But what it really means to me is that once you've set your data set up, the code to produce a quite complex visualization is very concise. So the idea behind HoloViews, the reason it exists, as I understand, is that if you're exploring your data, you don't want to write 20 lines of code to get a nice visualization because it's a distraction. If you're producing a plot for an audience, it doesn't matter. But if you're just going through and exploring your data and trying to understand what's going on, pausing and writing 20 lines of code just to make a plot gets in the way. HoloViews uses other libraries to do its actual rendering, so it can render to Matplotlib, it can render to bokeh. If you render to Matplotlib, you get the advantages of Matplotlib, like all the pretty controls. If you render to bokeh, you get interactivity. I believe there's an experimental renderer to Plotly. Its main drawback, if you feel it as a drawback, is that it's quite a learning curve because it is different. It's different conceptually and syntactically. So of all the libraries I learnt in researching this talk, this one took me the longest, but I'm glad I did. So I guess that's the trade-off, right? It's whether you're trying to find something that you can just get into really quickly or whether you want to do something that's powerful but you need to maybe put in some time to get your head around it. So I'll just show you a couple of things that it can do. So I hope this is legible. I can make it bigger if it's not at the back. All good? No one's complaining? Okay. So the first thing I have to do is I've got my tabular data. I'm actually going to subsample it slightly, but I'll keep most of the points. I need to make a HoloViews data set. And I've got KDIMs. KDIMs are the things I want to look up my data by. I might want to slice it on them or facet into different plots based on these variables, or color the points differently based on these variables. So I've put in sex, what is the product of, and what is the body part, right, as my variables that I want to be able to look up. VDIMs are the variables I might want to plot as functions of these other things. That's the rough idea. And so I've put in age and day and incident count and narrative. Once you've made your data set, you can kind of look at what's inside it, right? It's got all these things. You can see the data that originally made it and all its parameters. But if you want to render something, here I'm making a scatter plot. So first I've said, just for now, throw away some of the variables because I want to make a simple plot first. So just keep these dimensions. And then I'm saying make a scatter plot of day against age, which is what we did before. And the first thing you'll see is there's a widget here. And the reason is that one of my dimensions was product, and I didn't tell HoloViews what to do with that dimension, and I didn't use it in my plot. So HoloViews automatically turns it into a widget that I can select from. So every KDIM is here to look up your data in some form or other. Either it's inside the plot or it's a widget to go over your plots. So here I could switch between basketballs and doors. This was day against age, right? So we saw that basketball injuries fall off over Christmas. I noticed when I was exploring this that knife injuries seem to spike over Christmas. I assume people are preparing food, right? Okay. Stairs and steps. So you can see there's a kind of a different age distribution for these things, and in some cases a different date distribution. So I'm going to repeat this, but this time I'll keep all my variables. I won't throw some away. I won't simplify it so much. And here I've used overlay sex. So overlay means I want to see male and female on the same plot, and basically they'll just be different colours, right? I'm slightly nervous every time I hit execute because if we have a Wi-Fi issue or something, it's all JavaScript based. It's thinking. Ah, hooray. Okay, so I didn't throw away any variables, so we've got both product and body part are left over. And so they've both been turned into drop-down widgets. If they were numerical variables, they'd be sliders. But because they're categorical variables, they're drop-down lists. So now we could ask, for instance, oh, and sorry, I should point out, I also said in the specification of how to present this plot, I said turn on the bokeh hover tool. So I said render it using the bokeh backend and provide me with a hover tool. So now I can say, how are all these people using the wall to injure their hand? This one is punching the wall. This one is punching the wall. Punching a wall. So, and look, it's fairly young people who seem to punch the wall, or at least, not younger than middle-aged people, both genders. But you can see it's nice, right? There were very few lines of code involved in this. There was basically one line of code. And I can ask questions like, when people are injuring their hand with the wall, what are the narratives? And I can explore it interactively. So I'll show you one more feature of HoloViews, and then I'll stop. There are more features. What I've done here, if you look at when I actually plot it, I've said bars plus scatter. That means I've made an element called bars, an element called scatter, just put them next to each other. And the reason I'm making this bar plot is I want to say, well, when I'm up here, when I look at, say, how are people injuring their eyeball with the wall, there's not many points, right? So I would like to know for the product I'm looking at, what parts of the body are people injuring with that product? Which of these drop-down lists are interesting? Which ones should I bother to select? So I've made a bar plot to say, aggregate over all the other variables and just show me how many people get injured on each body part for the product I happen to be looking at now. And I won't go through the syntax. And when I say plus, you can see it just puts them next to each other. It still gives me the variables that I haven't used. In this case, the body part actually is used in this graph, but it's not used in this one. So when I change the body part, the left-hand graph won't change, but the right-hand one will. Right? So on the left-hand one here, I can see that for basketball, it's usually ankles, fingers, fair bit of head and knee, right, that's getting injured. And so I could choose that, and then I could mouse over to say, how are people injuring their ankles when playing basketball? We're nearly at time, so I'm going to stop showing you things. There's other nice features of HoloViews. I guess the take-home thing is the syntax is different to stuff you may be used to, but it is very concise. Like, I set up my data set, and I can do all these things really well. So in fact, in Tennessee's talk, what would be good in a data hackathon, this would be excellent so long as you already know it well. You wouldn't be learning this in a data hackathon, but it would be great for exploring your data. All right, so let's go back. So we've got 5 minutes. I'll use those 5 minutes, firstly, to say this. I think that this may be what people really want, and it's a scary slide to write because it's very personal, right? And everyone's opinions differ. So these are just my suggested starting points. If you want to produce static publication quality graphs, I would recommend Seaborn. If you want to get started with interactive plots and you don't want a huge learning curve, then I think Bokeh and Plotly are both really nice. They have slightly different strengths and weaknesses. Altair is fairly young and its documentation is fairly young, but I think it's going to be really interesting. I didn't talk about it much, firstly because it's young, and secondly because Jake van der Plas is involved in that project and he talked about it fairly extensively in May, so you can go and watch his talk and hear all about it. I think Plotly has the feature which may be positive or negative in that it has this business model, which may be a good thing depending on what area you're working in. Whole of Users in Bokeh is really good for interactive data exploration. I didn't talk about it, but there's been a lot of talk about data shader recently as a way of handling really large volumes of data when you've got like millions or maybe billions of points. You can't just plot those on a graph because of performance and also because of overplotting, right? Once your plot points get to a certain density, you can't see how many there are anymore. So you need something that works out appropriate binning or density rendering of your plot and sends the pixels to the browser, not the points. And data shader is one of the things that does that. Another is, I don't know how to pronounce it, VX. And I've got to say that as we get towards the bottom of the graph, these are less things that I have personal experience in and more things that I hear people talking about. I don't really work with geographical data myself, but people have talked to me about IPy leaflets. So actually after this in the questions, if people have particular recommendations, especially for those bottom couple of things, maybe you could share them. And this very last thing, this is really interesting and I just didn't have time to fit it in. There's a few things that let you build your own dashboard or your own web app that explores data, where the front end talks to the back end and it's pretty much a fully featured app, but it's very easy to write. Plotly Dash is one that came out not too long ago and people really like it. Bokeh Server fills a similar niche. BQplot, I wish I had had more time to talk about BQplot. It works closely with IPy widgets, which are the Jupyter Notebook's preferred way of doing widgets, so sliders and drop-down lists and things. Putting a BQplot plot together with widgets and wiring them up is a nice way to get a dashboard as well, and it's probably the most notebook native way to do it, right? It's not a standalone web app, it's in the notebook. So, I guess, how long have I got? I think I've managed to rush through things slightly faster than I thought, so I'm going to go back and say, this is one I didn't get to talk about, Plotly. It's been neck and neck with Bokeh, I would say, in some sense, in that some people like it more and some people like it less. It has a declarative JSON schema, not Vega or Vega Lite, but its own schema. Like pretty much anything that has a JavaScript library, at some point the Python library has to specify the plot as an object and hand it over to the JavaScript library. And in the best cases, that's done in a transparent way so that you can see the specification and modify it, and it's a declarative object. And it does do that. It was originally something very much based around online use, but they've now kind of fully open sourced the JavaScript library. You can use everything offline. I think there may still be some restrictions on unpaid accounts, possibly exporting to certain file formats. And it's cross-platform. So it's quite nice if you're getting started quickly and it has the chart types you want. It probably doesn't give you as much low-level control as Bokeh, that's my feeling. BQplot I was just talking about, it's very interesting. It's much more lightweight than, say, Bokeh. And it's probably not intended for huge quantities of data. All right, I have to stop. But it's not intended to do everything. It's intended to work with IPy widgets and other libraries to accomplish what it accomplishes. Okay, so I think I've run out of time, so I'm just going to say, what have we learned? And don't punch them. Okay,
All right.
questions?
Yeah, let's.